So whenever we're trying to simplify, and that's what it's asking us to do here, we're trying to simplify an expression to only a single trig function, or as simplified as it possibly can get. In all of these problems, whenever you see a reciprocal function, one of the main things, or one of the things that you should do, is instead of writing the reciprocal, you should write the original function. So if I have cosecant of x, you can even look at this on our trig identity. If you have cosecant of x, cosecant of a variable is equal to 1 over sine of that variable. So instead of rewriting cosecant of x, I'm going to replace it with 1 over sine of x. So if ever you're stuck in a trig identity problem, a go-to is look for any reciprocal function and replace it with the original function under. Now, we've simplified cosecant. This is next. Can you locate that? Cosecant of pi over 2 minus x. Can you locate that on our trig identity? I feel like I've been talking a lot of. Can you find it? Ah, I think Serena found it. If you guys look at the co-function identity, what this section does is it compares a function to what it's called. So sine goes with cosine goes with sine, cosecant goes with secant, secant goes with cosecant, tangent goes with cotangent, and cotangent goes with tangent. So it here says sine of theta equal to cosine of pi over 2 minus x, or sorry, minus theta on our sheet, which is just a variable, we can replace it with x. This makes sense, right? Because if we're thinking about a sine function, we can create a cosine function just by shifting 90 degrees or pi over 2 units, pi over 2 angles, right? It's just a shift. So that's what this identity is stating. We can replace this entire thing with sine of x. So this becomes 1 over sine of x times sine of x. Can this be further simplified? Mm-hmm. Yes, Jeff. Why? What happened? Let me show you this. Ah, we have a sine of x in the numerator and a sine of x in the denominator when multiplying, meaning they can cancel, leaving us with 1. Leaving us with 1. A lot of problems will simplify to 1. Not all, for sure not all, but a lot of them will simplify to 1, which is very satisfying, right? This big log thing, all of it is just equal to 1. Okay, number 2. I have 1 plus tangent squared of x over 1 plus cotangent squared of x. Now remember, if I was to look for this entire thing on my trig activity sheet, I wouldn't find it. I'm going to tell you right now. You should search to see, okay, is this an identity? And I'm going to tell you right now it's not. However, when I split it into 2 separate things, if I'm looking for just the numerator, 1 plus tangent squared of x, I should be looking for this, but also I should also be looking for tangent squared of theta 1. Do you see either one of these, 1 plus tangent squared of x or tangent squared of x plus 1 on my sheet. Remembering that x on our sheet will be replaced with theta. Yes? What do you see? Exactly, yes, exactly. So, give me 1 second. Just had a thought. All right, so yes, exactly. 1 plus tangent squared of x is the same thing as secant squared of x. That's what it says in the middle function of our present identity. It says tangent squared of theta plus 1 is equal to secant squared of theta. So what I'm going to do is I'm going to replace that numerator with secant squared of x. And I'm going to do the same thing. I'm going to look for 1 plus tangent squared of x or the reverse, cotangent squared of x plus 1. Do you see that? In the same area, right? Right next to it. It says cotangent squared of theta plus 1 is equal to cosecant squared of theta. So this whole denominator can be replaced with cosecant squared. Now our variable. Now remember what I said. Whenever you have reciprocal functions, what is a solid move to make? Yes, well, the reciprocal. You write the reciprocal. So secant is the reciprocal of cosine. So I'm going to write 1 over, now this is the squared version, so it's cosine squared of x, all over cosecant is the reciprocal of sine, 1 over sine, no, again, it's the squared version. What can you do now, you think? What's our big issue now? Yes, multiply by the reciprocal of the denominator. Anytime you have a big fractions are messy, right? They can for sure be simplified. We can simplify them by taking the numerator and multiplying it by the reciprocal of the denominator. What what does this simplify to? That is, jog your memory a little bit. What does this seem very similar to? Ah, sine over cosine, which we know is what tangent is. So if we have sine squared of x over cosine squared of x, you better bet this is the same thing as tangent squared of x. And this is a single trig function. So this is as simplified as I can go. And I'm done. So all of that simplifies down to tangent squared of x. So like I said, I'm going to pause this now and I will. All right, so let's do the rest of these examples. Here, remember, I told you that whenever you're looking at an expression that you're trying to simplify down to a single trig function using identities, whenever we have a reciprocal trig function, a go-to solid move is to instead write the reciprocal original function. So if I have secant of theta, what you would write is 1 over cosine of theta times cosine of theta minus
cosine squared of theta. Now notice here, I'm multiplying 1 over cosine of theta times cosine of theta. Well, guess what? That cosine of theta is over an invisible 1. Whenever we have a like term, when multiplying between the numerator and denominator, they cancel, leaving us with 1. This whole thing simplifies down to 1 minus, whoops, cosine squared of theta. Now we have to look, is this our final answer, or do I have a trig identity that has 1 minus cosine squared of theta in it? So I'm looking on my trigonometric identities reference sheet, and I'm looking for a 1 minus cosine of theta. So here's our identity sheet, and I'm looking. I can't actually find exactly 1 minus cosine squared of theta. However, if you look at the Pythagorean identities, if we look here, we have sine squared of theta plus cosine squared of theta equals 1. If I rewrite this, if I just move the cosine squared of theta over to the right-hand side by subtracting it over, this becomes sine squared of theta. I'm not going to have room there, actually. Let's zoom in. Oh, I didn't mean to. Okay. So if I'm subtracting cosine squared of theta over, it becomes sine squared of theta is equal to 1 minus cosine squared of theta, which is what I was looking for. 1 minus cosine squared of theta is sine squared of theta. So on my notes, on my problem, 1 minus cosine squared of theta can in total be replaced with sine squared of theta. And that is a single trigonometric function. I am done. That is as simplified as it can possibly get. On to the next one. Now this looks like a doozy, but we have sine of theta over cosine of theta plus cosine of theta over sine of theta all over 1 over sine of theta. Now whenever we're dealing with huge fractions like this, we want to simplify, think about simplifying the fraction first. Now in the numerator, I have 2 fractions. If I want to simplify this, what you have to do is you have to create a single fraction in the numerator. So the first thing I'm going to do is try to add those 2 fractions together. Right now, they're unaddable because I have unlike denominators. So my first step is actually to get common denominators. I do this by multiplying by the other fraction's denominator. So the sine of theta over cosine of theta, I'm multiplying by sine of theta over sine of theta. We always have to multiply both the numerator and denominator because sine of theta over sine of theta is equivalent to 1. So I'm not actually changing the value. I'm not changing the magnitude or size of this. And then I'm multiplying this fraction by cosine of theta over cosine of theta, because now this turns into sine squared of theta, right? Sine of theta times sine of theta is sine squared of theta over sine of theta times cosine of theta. And I'm just going to immediately put this into one fraction by adding the numerators over the same denominator. So I have sine squared of theta plus cosine of theta times cosine of theta is cosine squared of theta. Now, I have no other way from my knowledge that I currently have. I have no other way to simplify this. So anytime you're stuck, you should look on your reference sheet for either the entire fraction or specifically just the numerator, or the denominator. Now we can't forget that this is all over 1 over sine of theta. So if I'm looking on my reference sheet, and you could have either simplified this down into one fraction first, or you can work on looking at this and seeing if this can't be simplified. all by itself. So I'm looking first on my reference sheet if either this entire numerator fraction is on here, or if the numerator in the numerator fraction is on here, or if the denominator in the numerator fraction is on here. So let's look over at our reference sheet. And I am looking for, crap, I forgot what I'm looking for. Back over here. So here I'm looking for either of those. I'm searching on my reference sheet for either the whole fraction, which is way too big to be on here, to be honest. So I'm either looking for the numerator or the denominator of the numerator fraction. And yes, it's actually what we were just looking at. Sine squared of theta plus cosine squared of theta is equal to 1. This is the numerator in that numerator fraction. So over here, this whole numerator actually is equivalent to 1. And we know that we're going to have to simplify this big fraction by multiplying the numerator by the reciprocal. So my numerator is now 1 over sine of theta times cosine of theta times the reciprocal of the denominator. So sine of theta over 1. Whenever we have, let's see what color, whenever we have a like term between the numerator and the denominator, they can cancel when we're multiplying fractions. So I have a sine of theta and a sine of theta. This becomes 1 over cosine of theta. Now, what do we know from our reference sheet? What do we know is equivalent to 1 over cosine of theta? Well, that's easy. This is the reciprocal function secant of theta. And you're done. That's a single trigonometric function. Okay, next one. Here we have 1 minus cosine squared of x times cosecant of x. So just like I've been saying, a solid intro move is to take your reciprocal function and write it as the original reciprocal, so 1 over sine of x. Also, we can combine 2 steps into 1. We were just working with this exact identity. I remember 1 minus cosine squared of theta, look, 1 minus cosine squared of theta is equal to sine squared of theta. So I can also replace, oh, and I'm sorry, it's an x in this example. So I can replace this entire thing with sine squared of theta. I'm sorry, x. Now here I'm multiplying sine squared of x times 1 over sine squared of x. So these are variable functions here, right? Our variable is what the function is applying to. So if I have sine squared of x, it actually means, if I was to write this out, that it's sine of x times sine of x, right? There are 2 of them. So if I actually have 2 sine of x's in that numerator, because it's over an invisible 1, I have a like term of sine of x and sine of x that can cancel. Just like if this had been x squared times 1 over x, right? The x and one of the x's would cancel, leaving us with a single x. So I don't actually need to write all this. I can just know, oh, come on now, that if I have sine squared of x in the numerator and sine of x in the denominator, the sine of x cancels and one of the sine of x cancels, leaving me with just sine of x. So that was an easy one. Next, and you'll see these identities just keep repeating. So again, look, we have 1 minus cosine squared of x again. We now know, and we can look back at it, we now know that 1 minus cosine squared of theta is equal to sine squared of theta. So over here, this entire numerator simplifies down to sine squared of x over secant squared of x minus 1. Now I'm just going to check, is that an identity? Let's see. So is there something with, what was it? A negative 1 and secant squared. So, oh, I see a 1 and I see a secant squared right here, but it's not exactly correct, right? However, if I want the 1 to be with secant squared, you can subtract the 1 over, and it becomes tangent squared of theta is equal to secant squared of theta minus 1, which is exactly what we had in our problem, secant squared of x minus 1. So this identity claims that secant squared of theta minus 1 is equal to tangent squared of theta. So on my problem, secant squared of x minus 1 is the same as tangent squared of x. So now, another solid move is whenever I have tangent, so I'm down to sine and tangent, both of the squared forms of those functions. Whenever I have a tangent, a solid move to make is to write it in terms of sine and cosine. Tangent is always sine over cosine. So this can be rewritten as sine squared of x over sine squared of x over cosine squared of x. Tangent is replaced with sine squared of x over cosine squared of x. So now this is a fraction with a fraction in the denominator. To simplify this, we take the numerator and multiply it by the reciprocal of the denominator. And look, we have a like term between the numerator and the denominator because this is technically over an invisible 1. Sine squared of x is both in the numerator and the denominator. It cancels, leaving us with just cosine squared of x as our solution. That is a single trigonometric function. It cannot be simplified anymore. Okay, almost done. Second to last one. So here I have negative tangent of x times cosecant of x times cosine of x. Solid move to make. Rewrite tangent as sine over cosine, and also solid move to make is to rewrite cosecant as the reciprocal. So I have negative tangent of x can be rewritten as sine of x over cosine of x. Cosecant of x can be rewritten as 1 over sine of x. And we'll leave cosine alone because it's as simplified as it can get, and it's over an invisible 1. So I'm looking now, noticing I have like terms between the numerator and the denominator. I have a sine of x, cosine of x, cosine of x. All of this actually simplifies down to negative 1. And last but not least, over here, we have cosine squared of x plus cosine squared of x times tangent squared of x. Solid move to make. You can look for NA identities first on your trigonometric identity sheet, but nothing really compares these two. So what you can do is you can take tangent, let's rewrite the first part, and write it as sine squared of x over cosine squared of x. So here we notice we have a like term multiplying. We have a like term between the numerator and the denominator. They cancel. So this is cosine squared of x plus sine squared of x. And I'm looking on my, I think we already dealt with this identity, but I'm looking on my reference sheet for sine, come on, unzoom. Sine squared of theta plus cosine squared of theta. Oh yes, it's another Pythagorean identity. Sine squared of theta plus cosine squared of theta is equal to 1. So this entire thing is actually just equal to 1.